Hello students, welcome back. Let us resume our discussion in section 3. We went through combining two or more inequalities through AND operation versus the OR operation. Now let's consider an application to that. What if we apply those to absolute value inequalities? We can consider this. Absolute value is less than A or less than or equal to A, in which case we end up with AND operation, or even better, you can express it as a double inequality like this or like that, depending upon whether you have strict inequality or semi-inequality. We went through these kind of cases already in lesson 2. Now the other case is far less important, but here they are. We end up with one expression, one inequality, expression is less than negative b or greater than b. If you use semi-inequality, less than or equal to negative b or greater than or equal to positive b, like that. These two cases are of course far less important, and they're not going to show up until calculus 2. The previous case, yeah, they sometimes show up, so let's talk about those. How about these? Well, you can immediately change this into a double inequality like this. And then you can either decompose into an AND system, or you can just go ahead directly with the techniques for solving double inequalities. Either way it'll work. We already went through this in lesson 2, so I'm not going to do that. I'll just show you the answer like this. Just set up and then use the technique for double inequality. Flip 2 to the other side, divide by negative 3 and simplify. In the end we get an open interval. Open interval for strict inequality. No surprise there. How about this one? Again the same deal. Negative 1 to positive 1, except that we have semi-inequalities for both. So flip the denominator to the other side in the like terms and simplify. We get closed interval. Now this one here is gonna be harder. We don't have just a single number. We have another expression here. So we're gonna get an AND operation. What am I talking about? Did I say AND? Excuse me. What am I talking about? OR operation. Is it OR operation? I'm not so sure either. How do I do this? Is it really an AND operation? Oh, it is an AND operation. Oh, come on. Way too hard. Okay, let's get this out of our system. This one here, okay, those are... Okay, and in this case, it's going to be OR. So this thing here can be rewritten like this. Or like that. So we can go ahead and solve this and solve that, and then put those two together through the OR operation. If you do that, you're going to get answer like this or that, less than -7 or greater than +7, and then solving those denominators and then like terms and then eventually final division, you get these two intervals put together through intersection. Did I say intersection? Sorry, through union. Or operation is the union. So we have two intervals like this. Yeah, that matches. This one too is going to be OR operation, less than or equal to -1 or greater than +1, like this. And how do you solve those? First, the denominator, and then the like terms because there's no parentheses, and then solving through final division, less than or equal to -5 or greater than or equal to 4. So we have these two intervals, and indeed yes. And this one, I'll throw that away. Too hard, too complicated. I mean, it works out, yeah, but never mind. Let's not get there. So, depending upon the direction of the inequality, the absolute value inequalities can become either AND operation or OR operations. AND operation is typically easier and more important for us. As for OR operation, please consider this as a preview of what's to come as a matter of fact. By squaring both sides, it becomes the same as a nonlinear inequality like this by taking the square. And this one, well, pretty much the same too. And this time 1 squared is just 1, so keep it there. So both of these can become nonlinear inequalities, and these kind of things are going to become important from, let's see, partly from lesson 8, but in its entirety from lesson 9. Similar thing goes on here as well, but those are much easier, and I have to say these types are far more likely to show up in the exam than these cases. So in terms of exam preparation, AND operation part is much easier, and consequently that's far more likely to show up in the exam. As for the OR operations, yes, our textbook author does spend quite a bit of pages there, and it does show up in the intermediate algebra textbooks too. But me, frankly, there are a lot of other important things as well, and I've never written OR operation problem on systems of linear inequalities ever in college algebra or anything else, and probably I'm not about to start. So that's where I'm gonna stop. I'll never say never, but okay, alright, but and dot dot dot, and you can fill that dot 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 on your own. That completes section 3, and we have section 4, but that's going to be an optional section, optional video, only for interested students.